Okay, in this video we're going to be looking at quadratics and their transformations. More specifically, we're going to be looking at the value of a, or the number in front of the x squared, and what exactly does it do to our parent function. So first of all, let's go ahead and take a look at that parent function, y equals x squared. You recall that a quadratic parent function is the graph of a u-shape, or what we call a parabola, and that's what I've got graphed in black over here. So this black graph that you see here is our parent function. The question is, what happens when we throw a number in front of that x squared? Like this one right here, 2x squared. What does that 2x squared do to our parent function? Well, as you can see, I've got that graph right here in red. And as you can see, this red graph is a little skinnier or narrower than our black one, our parent function. So all the 2 did was make the graph narrower. Alright, now if you look at the next equation I have here, the new function we have is y equals 5x squared. Notice I've got that one graphed as well. That's this blue one here. And notice that this graph is even more narrower or skinnier than the red one. Alright, so that graph became narrower as well. So what's happening is, the larger and larger this value of a gets, the skinnier and skinnier the graph becomes. And the reason that happens is because what we're doing is we're taking these graphs and we're stretching them out vertically. It's kind of like a rubber band. If we take the top and bottom of our parabola and stretch it out, well, the more we stretch it out, the skinnier or narrower it becomes. So you can imagine if I had given the equation y equals 8x squared, well then this graph would even be skinnier or narrower than the other 2. So again, the bigger or the larger that number value a gets, the skinnier and skinnier the graph becomes. Again, that's because we're stretching this graph out vertically. Alright, let's continue looking at the value of a. What exactly does a in front of the x squared do to the graph? As we saw a second ago, the larger and larger that value gets, the skinnier and skinnier the graph becomes, and that's because we stretch it vertically. But what if instead of getting larger, the value becomes smaller, such as this one right here, y equals 1/2 x squared. So again, I've got my parent function graph. That's the black graph. Now if you look this time, this red one here, 1/2 x squared, has been graphed. But notice this time, instead of getting skinnier or narrower than the parent function, this graph became wider. And if you look at that second one we have here, y equals 1/4 x squared, notice how that value is smaller than 1/2. And this is the graph of 1/4 x squared. Notice how this graph is even wider than my red one, wider than the 1/2 x squared. So this time, as the value gets smaller, the graph becomes wider. And that's because this time what we're doing is, instead of stretching out our parabola, we are compressing it. It's kind of like somebody coming over here and stepping on our parabola and squashing it down. We're squashing it down vertically. Okay, we're calling it compression. We're compressing it vertically. So this time, as the numbers get smaller, the graph becomes wider. Alright, let's continue looking at the value of a, the number in front of the x squared. This time you'll notice that I put a negative sign in front of the x squared. And what happens here is we end up flipping the graph over the x-axis. So this time what we have is a reflection. And when we say reflection, to be more specific, we're saying that we have a reflection over the x-axis. We're flipping the graph over the x-axis. That's all the negative sign does. It flips it over the x-axis. Now you'll notice on the second graph I have here, the blue one, there's 2 things that's happening. The negative sign, as I just mentioned, flips the graph over. That's what that's responsible for. The 2, however, makes the graph skinnier or narrower, as we mentioned earlier. So this blue one not only is flipped, but it's also being stretched vertically. We're making it skinnier, more narrow, and that's because of the 2.